Let's talk about transformations. It's the last little bit of this unit we need to cover before we can start doing some, or putting this all together and doing some old IB exam style practices. Now, when we're talking about transformations, there's three real types we need to take into account: shifts or translations, stretches, and reflections. Within these, we're always going to be thinking about two different axes, right? You've got the x-axis and the y-axis. So basically, what is happening when you're shifting stuff up or down or left to right? When you're stretching stuff vertically or horizontally, or when you're reflecting stuff over the x-axis, vertical reflection, or a horizontal reflection over the y-axis. Let's do these one by one, starting with the shifts translations. You can use either of these words, by the way, and they come up pretty much interchangeably. So, probably the simplest one at all is a vertical shift. A vertical shift literally just means we're taking a function f of x and we're adding a constant to it, 3, or we're subtracting a constant from it, minus 6. And in this particular case, that would denote a positive 3 vertical shift or a negative 3 negative shift. So in this example, if we have a function that looks like this little parabolic function, a plus 3 vertical shift would basically just shift the whole thing up 3 units. In fact, we can denote this as 3 units. Similarly, if I were to redraw the axes for this same function, but I would do a negative 6 vertical shift, or I would subtract 6 from it, it would just shift this whole function down by negative 6 units. That's what a vertical shift is, and this is the kind of notation. You take an f of x function and you either add something or subtract something from it. Horizontal shifts are a little bit trickier because whenever you're dealing in the horizontal direction, it's kind of counterintuitive because the positives and negative signs are flipped. What does that mean? This is basically telling us that if I have an f of x function, and let's say I subtract 1 unit, or I want to shift it by 1 unit, this f of x minus 1 is going to correspond to a positive 1 unit shift to the right side. So what you got to remember for the horizontal case is that they're always, the sign is not corresponding to the same direction, it's opposite direction. Let's look at that same kind of function. If it's a little bell-shapey like this, and I want to translate it by 1 horizontal unit to the right, or f of x minus 1 would lead to a 1 unit shift to the right side. That's always going to be the case. So the vertical case is more intuitive, the horizontal case a little bit less intuitive. Cool. Let's talk about stretches now, the second kind of transformation we need to know for the IB syllabus. These also go hand in hand, vertical and horizontal. They're actually pretty similar to each other, unlike the vertical and horizontal shifts that are kind of working in different directions. But again, the vertical one is a bit more intuitive and a bit easier to get a grasp of. Let's say I have a function f of x, and it looks like this. It's that same kind of parabolic shape as we had earlier. If I were to do a vertical stretch, I would take a coefficient of, let's say 3 in this case, whatever, and I would multiply it by that function, f of x. 3f of x. So 3 times that function. And when we say it has a vertical stretch, what it would really do is it would make this look more cone-like. It would vertically enhance this, or compress this function by 3 times the amount. So it would make it 3 more times as more compact or compressed. That's kind of what a vertical stretch does. If, however, I would say, well, let's say in an alternative universe, I wanted to multiply this function by 1/2 of x, it would make this function, let's do it like this, 1/2 times as compressed, or it would make it a little bit wider. So for a vertical stretch, whatever the coefficient is, whatever you're multiplying that the whole function f of x by, is going to either, if it's a number bigger than 1, make it more compressed or squeeze it together, or if it's a number that's less than 1, it's going to flatten it out or expand it out. Maybe you've guessed it, but the horizontal one literally works in the exact opposite direction. So let's say I have that exact same f of x function that looks kind of parabolic. And instead, the IB asks you, hey, what do you think happens to this function if I multiply it, if I transform it by plugging in an f of 2x into it? So you transform it by multiplying the x term inside the f of x instead of the whole f of x function. Well, kind of ironically, this ends up leading to a transformation where the function gets expanded. It doesn't get compressed by twice as much, but it expands out by 1/2. So in other words, it gets twice as fat or 1/2 as compressed. It's the opposite direction to what we would see in the vertical stretch case. Kind of conversely, though, we might as well, for the sake of consistency, do both directions. If the IB asks you, hey, what would this kind of transformation look like? F of 1/2 of x. Well, in that case, if we go back to our little diagram, that would, like in the case of the vertical stretch, squeeze the function inside and make it more compressed twice by 2 times. So just like in the previous case with the horizontal shifts where the pluses and minuses go in different directions, in the case of the horizontal transformations, the coefficient that you're manipulating the x variable in the inside of the function also is inverted. So f of 2x leads to a 1/2 as stretched, and f of 1/2 of x is twice as stretched. It's kind of confusing, I know it is, but as long as we can remember that for the vertical cases, it's always going to have a one-to-one kind of correlation. But with the horizontal cases, the things work in the opposite directions. Pluses means minuses, and minuses mean pluses. Times 2 means really divided by 2, or times 1/2 means multiply by 1/2. You're good to go. Last little bit of this puzzle. What about reflections? So in other words, what does a reflection across the x-axis or over the y-axis look like? And we start with the x one. If we think about this, say we have an equation again, or a function that looks like this, f of x, and we're saying, hey, we want to reflect this over the x-axis so that it looks like this, assuming it was symmetrical. What exactly is that doing? Well, literally all we're doing in this particular case is we're taking every single one of these y values for this equation, and we're not doing anything to it. We're not shifting it. We're not stretching it. We're literally just making all of those y values negative. We're making them all negative. That's exactly what a reflection over the x-axis looks like, or would like more intuitively means. And to do that, we take our original f of x function. Guess what? It's pretty simple. We literally just make it negative. The negative f of x command translates into a reflection over the y, or the x-axis, excuse me. Now, let's think in the kind of opposite direction. Say, or what about for the y-axis case? Say we have a slightly different function that looks just like this. Some kind of little exponential function. And I wanted to reflect it over the y-axis so that it looks like this instead. Well, as we see here, the y values aren't changing, right? The y values are still positive. But what we're doing is we're taking this positive x value and we're mirroring it so it becomes negative. This one is becoming negative. This one is becoming negative. They're all just basically being turned from positive to negative. So all of the x values are being turned negative, which means that we're taking our f of x function, we're taking all of our x values, making them negative, and that is going to give us a reflection across the y-axis. Sometimes we can call this a vertical reflection, or because it's dealing with the vertical axis, and the reflection across the x-axis can be a horizontal one, but usually it's more common to refer to the axes themselves. That's it. Negative f of x, reflect over the x-axis. F of negative x, reflect over the y-axis. So now you know. The IB is going to then ask you, can we put all of these 3 different kinds of transformations together? And we'll work through some examples, don't worry.